Okay, maybe we should just get started on this. Hello everyone, and welcome to today's webinar on Dose Plus, our AI-powered dose prediction solution for radiotherapy. As you will see, Dose Plus supports fast, consistent, and personalized treatment planning. And it does this by generating 3D predicted dose distributions based on each patient's unique anatomy. And now a little bit about us. So as you all know, we are MVision AI. We help oncology professionals accelerate treatment planning and improve outcomes with AI-driven solutions. Our GBS technology is used in over 20 countries and supports treatment planning for more than 190,000 cancer patients every year. Today, Rachel Buckingham, our clinical success specialist, will walk you through our newest innovation, Dose Plus. She'll also give a live demonstration so you can see how it works in practice. And after Rachel's done presenting, we'll have a question and answer session. So please feel free to write questions in the chat and we'll get to those at the end. And with that, I will hand you off to Rachel.
Perfect. Thank you, Kevin. Hi, everybody. My name is Rachel and I'm Clinical Success Specialist here at MVision. Previous to this role, I was actually a radiotherapy planner at a hospital in the UK and an MVision user as well. So I have a little bit of user experience as well coming to you today. But yes, very excited to share with you all things Dose Plus. Hopefully everybody can see my screen and hear me okay. And we'll get going. But firstly, just thank you to everyone for taking the time out of your busy day just to learn a little bit more about Dose Plus. So I hope you find it beneficial today and it gives you really good insight into this new release. So Dose Plus. Dose Plus is an AI-driven solution designed in the first release to enhance VMAT treatment planning for prostate cases and male pelvis lymph node patients. So with Dose Plus, we believe we are streamlining the treatment planning process, improving efficiency, and facilitating truly personalized planning. So Dose Plus is a software-only medical device, Class 2A under MDR, 510(k) pending, not yet available for sale in all markets. So Dose Plus generates personalized dose predictions with a single DICOM send, using patient-specific geometry to serve as your starting point during plan optimization. So we know that with radiotherapy planning, this requires trade-offs between our target coverage and our organ at risk sparing. And traditionally in planning, this process has been highly human intensive, involving numerous re-optimizations, relies very heavily on both the planner's expertise, and also having some standardized planning templates in place as well. Whilst this approach is effective, it does often fall short in addressing the anatomical variations of individual patients. And it can also be very time consuming, having to re-optimize many times. And what Dose Plus is doing is it's bridging that gap between your standardized planning and a truly personalized planning approach by providing you with tailored starting points for your optimization that are based on the patient-specific geometry. And this also helps planners explore potential for further OAR sparing while still maintaining optimal target coverage. So Dose Plus, the software itself uses locked and specialized machine learning models tailored to some clinical context. So this would be the prostate, for example. The software will always prioritize the target. Variations in dose and fractionation regimes are supported well. And this is also as well as multiple overlapping targets or different dose levels, for example. Just like with our Contour Plus, the dose prediction software can be customized through a configuration user interface. And this includes dose scaling preferences as well, according to your clinic's preference. So some key facts for you about Dose Plus to begin with. Dose Plus is ready to use. Much like Contour Plus, it acts like a background service located on the MVision cloud. With the dose prediction software, there is no manual setup required to create the model. You do not need to train models with your own data, for example. The models are refined and they're ready to use. And Dose Plus has been developed internally. It does use a different dedicated AI architecture than our contouring software. So by incorporating Dose Plus into the clinical workflow, there is potential to increase efficiency while still maintaining your plan quality. Increased consistency between different planners is also an expected outcome with AI guidance. And it's able to do this through several key innovations. So personalized plan generation. So the system analyzes individual patient anatomy from their CT images and structure sets, and it generates a tailored dose prediction that accounts for that patient's unique characteristics. So by providing a personalized starting point for the plan optimization, Dose Plus is really moving beyond that one-size-fits-all planning template. And this is a point that would have been really significant for me in my previous role as a planner, to have the ability to move beyond those standardized templates. That's just something that really struck me as a previous planner. Pre-trained and ready-to-use models. The system utilizes static pre-trained models that do not require fine-tuning or any local data. So this ensures that the users have immediate value without any extensive setup, and consistent performance across different clinical environments. And much like with our Contour Plus, we are TPS agnostic integration, so we can seamlessly integrate with any DICOM compliant treatment planning system. And what's really special about Dose Plus is that it has the potential to benefit the oncologist, the physicist, and the planner. So the clinical benefit is seen across the wider team. So Dose Plus works similarly to Contour Plus, as I've mentioned. DICOM CT data and RT structure sets are sent to a specific DICOM destination, which can be personalized within the MVision configuration user interface. The dose prediction can then be sent back, a DICOM RT dose to your predefined DICOM destination, which would tend to be your treatment planning system import folder. So a typical workflow is with Contour Plus segmentation. You would review and edit your OARs where necessary. You would then have manual target contouring by your clinician. The dose specification in the PTV naming would trigger DICOM sending to either your A title MVDP pelvis lymph node or MVDP prostate. The DICOM export filters need to be configured on the TPS side, and the results are sent to your predefined DICOM destination with MVision configuration. For those of you that are variant Eclipse users, the RT dose can be imported through external beam planning using DICOM RT dose import or your standard DICOM import export application. So just to cover some technical aspects for you, both prescribed dose and units, which are grey or centigrade, they're both supported, need to be specified in the target names. This is how Dose Plus recognizes the target. It's all within the PTV naming. If the name matches the user specified pattern, then the ROI is classified as your target. There are also a few mandatory OARs that are required for prediction quality purposes. And for our first release, Dose Plus 1.0, these organs at risk are your body, rectum, and bladder. The expected OAR names, though, are also configurable. So the planning process begins with the transmission of your CT images and your RT structure set. The target volumes with the corresponding dose prescriptions are automatically identified from the structure naming using a configurable regular expression pattern. And the system is capable of handling complex prescription schemes. And this does include your simultaneous integrated boosts. And it also includes those that have multiple overlapping targets with multiple dose levels. So the workflow itself maintains our data privacy standards, such as GDPR for our EU customers and HIPAA for US. The data is pseudo-anonymized locally and encrypted during transport. And as you probably know, we use region-specific cloud deployments. The data flow is managed by the MVision connector, which is a locally installed component that handles your DICOM communication, data pseudo-anonymization, and secure transfer with the MVision cloud services. So for customers that already use MVision with Contour Plus, this component is pretty much identical, which enables seamless integration across MVision's AI solutions. So upon receiving your anonymized patient data, the AI model generates an achievable dose distribution based on the patient-specific geometry and prescription. And these distributions can be scaled according to how you have defined your criteria in Config UI. And this does include target mean dose normalization or coverage-based scaling. And then following a secure transfer back to the clinic, re-identification through the MVision connector takes place, and the predicted dose distribution can then be imported into your TPS for analysis and review. So within here, the users can evaluate your organ at risk doses through your DVH as you normally would do. They can extract achievable optimization objectives to begin your plan optimization. So you're using these patient-specific starting points as your optimization objectives. So this streamlined process enables rapid transition from sim to optimization, whilst maintaining full user control over the final planning process. So with the configurable nature of the system, we are allowing institutions to adapt the workflow, but to adapt it to your specific clinical needs, and you still very much have full user control over the final planning process and plan approval. So it's an easy installation process. Dose Plus only requires the MVision connector to be installed locally. And if you are Contour Plus customers, you will be familiar with this component. The prerequisites are minimal, can be installed on a small Windows VM. So the MVision connector is in charge of data transport, pseudo-anonymization, and re-identification. So the first release, this is our Dose Plus 1.0. It's providing you with 2 specialized models in the first release, and these are prostate and male pelvis lymph node treatments. As I mentioned before, the models are vendor agnostic, and they're predicting VMAT delivery less or equal to 10 MV. And as I've mentioned, again, planning preferences, so this is your normalization, for example, can be defined by the user. So this is typical VMAT dose distributions predicted by the Dose Plus models for both contexts. Regarding limitations and considerations that the planner needs to make. So while Dose Plus is offering you numerous advantages in terms of clinical potential, it's always important to understand the validated scope of use. So the system maintains strict prioritization of target coverage in all scenarios, so ensuring that the critical aspect of the treatment plan is never compromised. However, this does mean that in cases where target coverage conflicts with your organ at risk sparing, the system will consistently prioritize maintaining the prescribed target dose. So anatomical variations, previous treatments, they require special consideration. So patients with metallic implants may experience suboptimal dose predictions in comparison to the treatment technique adopted in this context. So similarly, the system cannot account for previous radiation treatments, which may affect plan priorities and tissue tolerances. So in such cases as this, we just state that additional clinical judgment is particularly crucial when evaluating and adapting your AI-generated predictions. So while the AI models are trained on diverse data sets, extremely rare cases or rare clinical scenarios may result in less optimal predictions. So as you know, clinical expertise will remain fundamental to the planning process. So Dose Plus is providing you with valuable guidance and efficiency improvements, and is designed to serve as your planning aid rather than a complete replacement for the human planner and the human judgment. So a qualified medical professional must always review, refine, and approve all treatment plans according to your clinical established protocol. So this is just sort of an example screen recording for you, but in my previous role, the main takeaway for me is how I can tailor my plan to this individual patient-specific anatomy, right from the first optimization run through. I'm not using these standardized templates anymore, where the optimization objectives that I start with have derived from a standard protocol that is so population generated. I'm beginning my optimization with patient-specific starting points. And in turn, this means that I will not be required to re-optimize so many times potentially. I am still very much in complete control of the planning process, but this software has allowed me to optimize with efficiency. So as a planner, I would always strive for the best for my patient every time. And it's hard to know when we're re-optimizing sometimes, to know when to stop. Is this the best that I'm going to be able to achieve? Is this the most optimal plan for this patient? And with the Dose Plus software, it's really providing me with this insight prior to starting my planning process. And this second screen recording is just taking a little while to load, so bear with me. But this was a screen recording of the pelvis and lymph node. Hurrah. So this is just a dose wash from the pelvis and lymph node run through the dose prediction software. And in cases such as this would more often than not fall to a more experienced planner, because they need to account for the trade-off between your low dose areas around the lymph nodes and the proximity to the bowel, for example, and keeping the bowel within constraints. And previous to this, I would need to think about using some kind of dummy structure or changing a dose level to a structure that will enable me to put some kind of objective on this area that covers the bowel, so that I can keep control of my low dose spill. But I've found with the Dose Plus predictions, these low dose areas, this is my 70%, 80% dose wash, I'm finding that they conform very well to the target, and shows very good sparing, particularly more superiorly around the nodal volumes where the spill would cross over to the bowel. That was just a little insight that I wanted to share with you. So before I move on to the demo videos, I just want to touch a little bit on the clinical validation. This is obviously very important to cover. So we have done our validation and testing, and here you can see the sites that were involved in these tests, and you can see the variation in treatment planning systems used within their testing and validation, as well as variation in dose prescription regimes. So let's take a look at some of the findings. So the key findings from these early tests did include high accuracy of dose predictions when comparing to our manual clinical plans, demonstrated feasibility of reaching predicted dose distributions using commercial optimizers, significant reduction in human planning time and iterations. And as I mentioned previously, this was an expected outcome, improved consistencies between different planners as well. So taking a look at each site in a little more detail, this study was presented at SASFRO 2024. The study examined 10 prostate cancer patients, and they had a particular focus on complex prostate cases that used the simultaneous integrated boost techniques. And this included dose painting. So the treatment planning was conducted using Varian Eclipse with 6MV flattening filter free, VMAT dual arc delivery, and the presented results showed that the AI-driven approach achieved comparable results when compared to manual planning for most critical parameters. The target volume coverage was similar between AI-guided and manual plans, with equivalent performance in the rectum and the penile bulb dose optimization. The model did demonstrate slightly higher efficiency in femoral head sparing. They showed reduced doses, mean doses by 1.5 gray. Some limitations were noted regarding the bladder doses, which were 4% higher for V25, although this was still an acceptable dose limit, and higher doses to the urethra and the arteries attributed to these structures not actually being included in the model's development. So with this particular piece of research, they did identify a path for our model improvement through the integration of additional anatomical structures, being the urethra and the arteries, into our future model iterations. So despite marginally higher monitor units in this case, DOSE Plus successfully demonstrated its capability to handle complex SIB planning scenarios without human interaction. So it's validated its potential for streamlining sophisticated prostate radiation therapy planning workflows. So as one of Germany's leading academic medical centres, University Hospital Mainz provided clinical validation for DOSE Plus, a rigorous clinical evaluation framework. So their study was presented at DGMP 2023. They examined 12 prostate cancer patients treated with integrated boost techniques, so 66 gray to the seminal vesicles, 80 gray to your prostate, again using dual arc VMAT delivery on Varian TrueBeam. So the study was structured to evaluate three key aspects: agreement between AI predictions and clinical plans, potential for plan quality improvement through AI-guided optimization, and clinical viability of plans created using AI-generated biological optimization objectives. So to highlight some key findings here, they demonstrated high concordance between AI predictions and clinical plans, whilst identifying opportunities for OAR sparing improvements, particularly for femoral heads, again, like the previous study. Plan reoptimization guided by AI predictions achieved reduced dose spreads in DVH without compromising the target coverage. The treatment plans created using DOSE Plus AI-generated biological optimization objectives did meet all clinical goals while maintaining planning efficiency. So they had a monitor unit increase of less than 5% compared to their conventional plans. The planning process efficiency was notable, with approximately 20 minutes required for initial plan creation and 10 minutes for reoptimization. So the medical team here concluded that while the AI system's benefits may be nice to have for your standard prostate cases, the potential value could be more significant for the complex cases, like prostate with lymph nodes or head and neck, for example. So the validation here really highlighted the system's potential as a quality assurance tool, suggesting it could serve as an independent check in the plan peer review process, which is an important consideration for clinical implementation. So the health centre in Capspa, they submitted to ESTRO 2025, validated DOSE Plus performance in the demanding context of SBRT delivery, so using hypofractionated protocols. So they analysed 20 prostate cancer patients treated with the SBRT regimen of 36.2 gray and 5 fractions. Again, they used dual arc VMAT on a TrueBeam system with 6 FFF beam energy. And this represents an important validation of the prostate model in contexts such as hypofractionated treatment scenarios. So the presented results demonstrated strong agreement again between AI predicted and clinical plan doses across all organs at risk. The mean doses showed correspondence with differences of less than 1 gray for the rectum, and approximately 0.8 gray for the bladder. The femoral head doses again were slightly lower with the AI predictions, while the urethra PRV doses showed a small increase. So notable technical aspects include processing time under 2 minutes for their dose generation, indicating the system's efficiency even for cases like this with SBRT, where we need to scan our patients with larger, thinner slices. It was still able to achieve this. The DVH analysis showed consistent agreement, particularly in high dose regions that are so critical for SBRT planning, validating the ability to handle these steep dose gradients and tight conformality that's required with these stereotactic treatments. So Newcastle, the validation study here at the Northern Centre for Cancer Care, they provided valuable insights into dose plus performance compared to both automated and manual planning workflows. So this is really important validation for those that already have some kind of plan automation in place. So the centre evaluated 30 standard prostate cases, 60 grey and 20 fractions, and 30 complex prostate cases with nodal involvement, and that was 60 grey and 47 grey in 20 fractions, using RayStation treatment planning system. So it's important to note here that even if you do have auto planning in place, such as RayStation, Dose Plus is still able to provide you with a benchmark or providing you with confidence in your planning outcomes from these automated processes. So for standard prostate cases, the AI predictions here showed excellent agreement with their already established automated planning solution. The V48 for the rectum, clinical plans averaged about 8.6% versus Dose Plus of 9.6%, and the V48 for the bladder, clinical plans averaged 13% versus Dose Plus of 12.1%. The more complex prostate with node cases demonstrated a particular value here for this site for their treatment planning efficiency. So these cases typically require the more experienced planner to balance that trade-off between their nodal target coverage against their bowel constraints. And this, as I mentioned before, often requires multiple re-optimizations. So Dose Plus was able to accurately predict cases requiring coverage sparing trade-offs in approximately 1/3 of these patients, so potentially reducing planning iterations. So this capability is especially valuable for this site, as they've seen a doubling in their prostate and node cases over the past 2 years. So this has really offered them a path to standardize their planning process, whilst also managing to maintain their increased workload. So the study validated the product's utility across varying complexity levels, and the potential for enhancing both an automated workflow and a manual planning workflow, particularly for the less experienced staff that need to be able to handle those more complex cases. And our final study here, the UMC Lubbock study, presented at AAMD 2024, provides a really important validation study from a major US centre regarding the Dose Plus implementation clinically. So this centre had already successfully integrated AI solutions into their clinical workflow, and they were looking at evaluating Dose Plus as part of their broader AI adoption strategy in order to enhance their radiotherapy quality and efficiency workflow. So the evaluation focused on prostate VMAT cases and examined the system's ability to improve plan quality and consistency whilst streamlining the whole planning workflow. So this study is particularly valuable as it represents experience from a centre that has already demonstrated significant workflow improvements through AI adoption. They highlighted how dose prediction tools like Dose Plus can complement any existing AI solutions to further enhance your radiotherapy quality and consistency. So specific dosimetric results are still being prepared for publication here, but the experience at this site suggests that AI-guided planning can effectively integrate into a department's broader strategy for leveraging AI to improve clinical efficiency and standardization. So I just like to highlight some clinical potentials with Dose Plus, some ideas that I have. This may also sort of spill over into our Q&A session. But with Dose Plus, we really see the potential to benefit not only the planner, but also the medical physicist and the clinician. We're really moving beyond the standard templates that are already found within the treatment planning system, moving beyond the one-size-fits-all population-generated protocol-driven templates here to a really personalized approach. Dose Plus has the potential to provide margin impact assessments, for example, investigating CTV to PTV margins and the effect that this could have on your OAR sparing. So it's really driving and supporting the clinical decision making. Similarly to this, looking at patient positioning impacts and how this impacts dosimetrically. The variation in patient positions and the equipment that's used. How does this affect the plan dosimetrically? Treatment plan adaptation assessments, so providing the physicist or the clinician with immediate insights into dosimetric impacts of any anatomical changes during treatment, if this is noticed on a cone beam, so supporting decisions for replan justification. The enhancement of treatment planning quality assurance, where the Dose Plus software is serving as a second check in the plan peer review process. The possibility that the software can provide additional support at MDTs where the predictions can be used during clinical decision making, meaning that a patient that's previously denied treatment or not for radiotherapy because they may predict that these doses aren't achievable. It may be that if they're run through the Dose Plus software, they can see that this is achievable and the patient in turn may be offered treatment. With regards to the Dose Plus MVision roadmap, so our first release, obviously we've seen prostate and pelvis lymph node. We do have other models in development. Obviously, this is continuous work. There's no timeline for these models as of yet, but it's just for you to know today, this may be questions, what other models are you working on? They are indeed in development and we look forward to sharing more with you on this soon. And the demo procedure, there will be a demo available. You would be granted a temporary license to use. It will be run via a web interface. Much like with Contour Plus web demos, data again is pseudo-anonymized locally on the browser before upload to the cloud. And this is something that we'll be able to share with you very soon. So moving on to some demos for you. If you are to have a go at using the Dose Plus web demo, this is kind of what you would expect to experience. So there wouldn't be any background configuration done at this point, but you would be using a web space much like this one, and you can manually select your target as I have done here, and you can manually input your dose and start, and it would run and you would receive a prediction back like this one. You can view your DVH and from here you could get some idea of the optimization objectives that you need to start with, and you could simply export this dose as a DICOM file and upload it into your treatment planning system. So that is an idea of how the web demo would work. You would manually be able to select your target and manually be able to input your dose. So once installed as a Dose Plus customer or user, how do you configure everything? How do you have control over your normalization and your dose scaling? So if you are already Contour Plus customers, you will be familiar with the configuration user interface. And this is the same for Dose Plus. So you can see here on the left-hand side, I have my Contour Plus options here. You will now see an additional option for Dose Plus model customization. And from here, the available models would be visible. You can select the model. And as with Contour Plus, you have a default model. Again, you can customize these extensively. This is where you can input your selection triggers and your AE titles. You can see it's MVDP prostate for this particular model, and you can configure the dose. So you can scale or predicted dose, whether you want this target mean or whether you wish to specify 95% of the volumes, 95% of the dose, for example. In plane pixel spacing, this can all be configured. You have the option of a supporting RT plan to be included if your treatment planning system requires this. The target and prescribed dose detection rules, so you can configure it to be able to identify this automatically. Gray and centigrade are supported, and the PTV naming is done via regular expression match pattern. So you are in control of how you want this to come across, what you want your trigger to be, and you can see your mandatory OARs here. So these are the mandatory OARs for the first two models in Dose Plus 1.0. So as you can see, it's still a very user-friendly interface. Everything is customizable. So as they say, here's one I prepared earlier. So this is just an example I wanted to show you of a more complex pelvis lymph node case. So this is already pre-configured with my 3 PTVs. You can see the naming has triggered the correct doses. I'm just checking here that I have the mandatory OARs required. And I can start my dose prediction here. It's already run it for me. But I just wanted to share this case with you because there's 3 dose levels and overlapping targets here. So just looking at my PTV 44, you can see the dose wash around the nodal volumes. And as I mentioned previously, it's very conformal to the PTV around these areas, sparing the bowel nicely. Moving on to my 56 gray volume, which is my prostate and SVs with a margin. You can see that the dose fall off is very nice here. This is something I can review in this space, but I can import it into my treatment planning system. And what this dose prediction is giving me, what this DVH is giving me, you can see these dose stats down here. So this is what I'm talking about in terms of how it's personalized. When I begin my planning process and I open my optimization window for the first time, I no longer need to import a standard planning template that has been put within my treatment planning system. I can use these dose statistics here. These dose statistics are more relevant to this specific patient because they have been run through Dose Plus and they are based on their specific anatomy. So this is really how we're able to achieve these personalized dose distributions, and I'm starting my optimization process from a much stronger position. So I hope you enjoyed quite a complex presentation there with some live demos. So we are at the stage now where I'm happy to take questions. Hopefully Kevin has already found some in the chat, but I hope you found that beneficial. And please feel free to type your questions in the chat if you don't want to turn your microphone on. And we can start a quick discussion. If there are any questions that I'm unable to answer today, if they're particularly technical, of course, I will take notes and speak to the wider team internally and get back to you with the best possible answer for you.
Okay, thanks, Rachel. Fascinating presentation, and particularly nice to hear that Dose Plus has been clinically validated in so many institutions. So unfortunately, we didn't get any questions in the chat, and you're still welcome to do that. We do have two pre-webinar questions that we collected, so hopefully you can answer these.
Sure.
So the first one is, hold on a sec. How can the plans be accurate without machine information like energy or call angles?
Okay, so yeah, so this is an important one to note. We are not generating an automatic plan. What we are doing with Dose Plus is we are predicting dose distributions, not plans. So the intent is to give a good, strong starting point for your plan optimization. So machine parameters such as your energy, your MLC, leaf width, your collimators, they play a minor role in your multi-arc VMAT plan quality. So what Dose Plus is doing is we are reflecting full dual arc 5 mm generic MLC for low to medium range energies, 6 to 10 MV. That's what's been included within the model training for both the prostate and the male pelvis lymph node models. And what they're doing is they're generating predicted dose distributions rather than a plan. So the machine beam geometry is not required here. Not until you import this dose distribution into your TPS. Using those optimization objectives, you then input them into your optimization for the plan that you have created, which uses your beam geometry.
Okay, great. And can more than one user use the license for Dose Plus at the same time?
Yes, so licensing for Dose Plus works in the same way as Contour Plus. So multiple users can share the license. Usually the license is for one site. As the tasks come through, they will be placed in a queue and processed in order. If for any reason there are timing issues, we can create additional processing servers to handle the workload. But at the start, it's unlikely that the queue will have multiple tasks frequently. So yes, just one license can be used by multiple users. And when tasks are sent through, they'll be processed in order.
Okay, great. Okay, so I guess that's it. So we'd like to thank you all for attending. And if you want to learn more about Dose Plus or schedule a demo, then feel free to visit our website or get in touch with Rachel. I'm sure she would be more than happy to show you Dose Plus in greater detail. And like Rachel said, we appreciate you taking time out of your busy schedule to be with us. And hopefully we are in contact soon. So thanks.
Yeah. Thanks, everybody.